All right, 11.1, circumference and arc length. The circumference of a circle is the distance around the circle, right? It's like the perimeter. We can see the circumference, it's that edge piece, and the formula for circumference is pi diameter or 2 pi radius, right? We know that 2 times the radius is the diameter, so really those are the same formula, they're just written in a little bit different way. That would be something that you need to commit to memory. Example 1, find the circumference of a circle with a radius of 8 meters. Well, I'm going to use this formula right up there. So I'm going to have the circumference is equal to 2 pi r, which is 2 pi 8, which is 16 pi. And I'm going to leave it as 16 pi because that's the exact value. Sometimes that's called in terms of pi, right? We leave the pi there. So that would be 16 pi meters. Example 2, find the radius of a circle with a circumference that is 35 centimeters. So we know that circumference equals 2 pi r still. So 35 equals 2 pi r. And now I need to divide by 2 and divide by pi. And what I'm going to use is I'm going to use the pi button on the calculator. If you don't have a pi button on the calculator, you could use 3.14. That would be just fine. So I'm going to type in 35 divided by 2, and then I'm going to press enter, and then I'm going to say divided by pi. I'm going to press enter, and that gives me that r equals, and I'm going to round to 2 digits, 5.57, or excuse me, for 2 decimal places. So 5.57, and that would be centimeters. All right. So the circumference is the distance all the way around, right? All the way around the circle. The arc length is a portion of the circumference, right? It's how long the arc is, right? Previously, we've talked about the arc's measure. Now we're going to talk about how long is the arc, right? If you're thinking about this with a pizza, then the circumference would be all of the crust of the pizza, right? All the way around. And then the arc length would be the amount of crust just on one slice of pizza, right? So here, this should be the arc length of arc AB is the measure of arc AB over 360 times 2 pi r. And here, let me just rewrite that. Measure of arc AB over 360 times 2 pi r. And let's talk about why this is. This is the circumference, right? And then this piece over here is the measure of the arc over 360. Well, in total, there are 360 degrees in a circle. So if this was like a 90-degree angle, then it would be 90 over 360, like percent of the circle, right? And 90 divided by 360 is going to be 1/4 or 1/4, right? You could think about the circle could be split up into 4 pieces, 90, 90, 90, and 90. So what we would be doing there is we'd find our circumference, and then we would multiply by 1/4, or we would divide it by 4, right? Because it's getting cut up into 4 pieces. So make sure we remember this formula. This would be another formula to commit to memory. We have the measure of the arc over 360 times 2 pi r. Example 3, find the arc length of arc AB. Well, I'm going to just plug into my formula. I have a 70-degree angle, so 70 over the total, 360, times 2 pi r, and my radius is 9. Now I'm going to type all this in my calculator, but I'm going to leave out the pi. That way the pi, I can leave it in terms of pi. So I'm going to say, well, starting off 70 over 360, I can cancel those zeros out. So I'll say 7 times 2 times 9, right? I'm saying 7 times 2 times 9. That's 126. Then I'm going to divide by 36, and I got 3.5, which is the same thing as 7/2. So this could be 7 pi over 2. And that would be the arc length. And do we have a units? We do. It's centimeters. There we are. So this piece, its length would be 7 pi over 2, which if we were to multiply in the pi, that would be 10.99. Well, really, if we round, it should be right at 11.0 centimeters. So a piece of pizza cut from this whole pizza would have a length, its crust would be 11 centimeters long. All right. Find the circumference of circle Z. So this time they gave us the arc length right there. We have our angle. And now we're going to have to kind of reverse work it so that we can get the whole circumference. We know that the arc length formula, and I'm going to plug into that, the arc length, in this case 5, would be equal to the angle, 45, over 360 times 2 pi r. Now, 2 pi r is the circumference, right? 2 pi r is the circumference. So I'm just going to substitute in, and I'm going to say, well, 5 equals 45 over 360 times circumference. Now, I just have to solve for c. So I'm going to multiply by, what am I going to multiply by? 360 over 45. Multiplying by the reciprocal there, so I'd have 5 times 360 divided by 45, and I have 40. So this would be 40 inches. Now, we all see what I did there whenever I plugged in the c there. Now, had I not done that, I would have been able to solve for r, and then I could have plugged back into the circumference. What would have happened, though, is I would have had to divide by a pi here to get the radius by itself, and that would have turned it into a decimal, and I would have had to round, and then I would have to plug it back in. So by doing it, by plugging in the c here, I'm able to get a true and exact answer. Whereas if I had used the r, I would have had the pi, and it would have given me a decimal. All right. Example number 5. Find the measure of arc RS. Thinking it's that one there. Yes. Remember, if it says arc RS and it's just 2 letters, it needs to be the minor arc. And to me, it looks like that one would be the minor arc. So we're looking for our angle. So that could be like x degrees. Find the measure of arc RS. Well, we have the radius here, so we could plug into the arc length formula. My arc length is 48. My angle is unknown, over 360, times 2 pi radius, which is 16. Now I'm going to start off by combining the 2, the 16, and the 360. So 2 times 16 is 32, and if I write a fraction with 32 over 360, that would reduce to 4 over 45. So 48 equals 4 pi over 45x. Now, whenever I solve for x, I'll multiply by the reciprocal. That would be 45 over 4 pi. On the right side, those cancel. On the left, let's take 48 divided by 4. That'd give me 12. Times 45 would give me 540. So my exact answer would be 540 over pi. But if I want my decimal approximation, I could divide by pi there, and I would have 171.89 degrees. Which that seems about right, because we were talking at the very beginning that this does seem like it's almost a semicircle, but it's just barely a minor arc. All right, looking on. Now we're talking about something new, a radian. So in a circle with a radius of 1, the radian measure of a given central angle can be thought of as the length of the arc associated with that angle. The radian measure of a complete circle, which is 360 degrees, is exactly 2 pi radians. Because the circumference of a circle of radius 1 is exactly 2 pi, right? That makes sense. That should make sense. You can use this fact to convert from degree measures to radian measures and vice versa. And as I say on to the side, if you're taking notes, you don't need to copy all that down. Let's look at this picture here, though. So radians are a new way to talk about angle measures, right? What it does is it says, we've always thought of angle measures and it's for any circle, right? What we're going to do here is we're going to kind of compare it to what's called the unit circle, the circle with a radius of 1. So here we have a smaller circle inside, it has a radius of 1, and then we have the larger circle, which is a radius of larger 1, right? The smaller circle has a radius of 1 and its circumference is 2 pi, right? The formula for circumference is 2 pi radius, but if you plug in 1 for the radius, you get plain old 2 pi. So say this was, I don't know what kind of angle, I don't know, we could say 45 degrees. No, we'll say 90 degrees. It doesn't really look like a 90-degree angle, but just for argument's sake. Then this arc here would be 2 pi divided by 4, so it would be pi over 2. Now, obviously that doesn't fit my picture there, but I'm just doing it for argument's sake. This here, we know that it is a 90-degree arc because we have that central angle there of 90 degrees. And what we're going to do is we're also going to describe it as pi halves, because that's what the arc length of the unit circle is, and we're going to be able to describe it using the unit circle. All right? It's a new type of measurement. It's a different way to measure. So let's look at converting between degrees and radians. Well, my formulas are gone. Hold on. Let me make sure that I'm getting these right. All right, that's what I thought. 2 pi radians, or 360 degrees, or pi radians over 180. So what are we saying here? We're saying the whole unit circle is 2 pi, right? Because that's the whole distance around. And the whole circle in degrees is 360. That's going to be our conversion factor. So if we have something degrees, like 180 degrees, we could convert it into radians. And that's what our next couple examples are going to be. We could divide by 2 on both of these, and we would get pi radians over 180, right? So that would be something to remember. Pi radians equals 180 degrees, right? That's a good conversion factor that we should remember, and then we can use. And then from radians to degrees, it just says it in reverse. You'd have 360 over 2 pi radians, or 180 over pi radians, right? And I'm going to show you a way to where we could just basically use that idea there, and we'll be able to know what we're doing. Right? Again, pi radians is equal to 180 degrees, right? If you're thinking of a unit circle, the circle with a radius of 1, then the circumference of a 180 degree angle would be pi, right? We've got our circle here. 180 degrees would be half of it. This would be pi, and down there would be pi, talking about the circumference, right? We're talking about the circumference of the unit circle. All right, example 6, convert 120 degrees to radians. So we have 120 degrees, and we're going to need to multiply by a conversion factor. And whenever we multiply by a conversion factor, we want the units to cancel. So I have pi, and I have 180. 180 is degrees, so I'm going to put it on the bottom so that it will cancel. And then I have pi radians on top. By doing this, my units, my degrees can kind of cancel, and now I'm going to be left with 120 pi over 180. And this will be in radians. I can reduce this, what is 12 over 18? Or is it not 12? Yeah, 12 over 18. That would be the same thing as 2/3. This would be 2/3 pi. Right? Example 7, convert 3 pi over 4 radians to degrees. Well, 3 pi over 4, we need to multiply by a conversion factor. We want the pi to cancel. So I'm going to need to put the pi on the bottom and the 180 degrees on top, right? I'm still using this 180 degrees equals pi radians, right? And I don't know if I said this earlier, but they're equal. So by doing this, we're multiplying by 1, really, right? Because it's the same thing on top and bottom. It's just kind of like a fancy 1. So I multiply these, my pi's cancel, and I have 3 times 180 over 4. 3 times 180 divided by 4 is 135 degrees. All right, that is that.